Hi everybody, this is Mrs. Lehman from Math with Mrs. Lehman, and greetings. I miss you guys tremendously, and today I am here to hopefully help you out with finding some answers to some challenge questions that you guys had assigned for this week. So this is overall your third assignment with Khan Academy, and it is your second assignment dealing specifically with mean and median. So two quick brief explanations I'm going to give to you to help you understand some of the concepts as we move through this video are the following. So first thing is the mean is the same as the average, and I know you guys are familiar with averages because that's how we score things, right, in school. So you take all of the numerical, meaning the numbers, all the numerical data, add it together, and divide by how many numbers you had. That will give you the average. So we're going to use that information to find missing values. So what happens if we know the average and we know some of the data, but we're missing a piece of data? How could we use the understanding we have of mean to find our missing value? Well, I'm going to walk you through that here in a minute. The second thing you need to understand is what the median is. The median is the data point where 50% of the values fall below that number and 50% of the values fall above that number. So it is the middle of the data. Now, one thing that is really great about the median is that it is resistant to something we call outliers in math. All right. So an outlier lies outside of the typical. It's not something that looks like the rest of the numbers as far as, how big or small it is. So if you have numbers that are all around 50 most of the time, and then you see a number like 2,000, right, that would be considered an outlier. It kind of hangs out by itself at the far end of the data. All right, so it's either really high or really low, and what that does is it will really affect the average or the mean, but it does not have that same effect on the median. So anyway, those concepts of what is the average and how do outliers affect the average, it pulls it in one direction, that understanding will really guide us through these sets of questions. So let's get this party started. So you'll see that there are 6 components to this assignment. A few of them, 3 are videos. There's one article that will walk you through the mean. As you can see, trust me, I know how to get to 100%, but I did get to 75%. Here's the good news, as long as you're trying, you get credit. So, quick note, again, and I know I've said this in the past, if you go to past under assignments, you can go back through and do some old assignments, because as long as you have that done, even though it was due on Thursday night, if you can get it done before I actually put it in the grade book, I will pretend that it's not late. How's that for being nice? All right, so let's go to the stuff that is due Thursday at midnight. I think that's the time I usually turn into a pumpkin. Okay, here we go. Missing value given the mean. I'm on the third thing down, and let's get to it. All right, ready to practice? Okay, you've got 4 questions to show us what you can do. 4 questions, 4 to 6 minutes. I think it takes longer than that, but whatevs. I mean, that's probably with me explaining it, but all right, let's go. That lovely noise you can probably hear in the background is my washing machine saying that some clothes are clean. Yay. All right. Missing value given the mean. Coins collected by each person in a scavenger hunt. Wow. That's a lot of coins. All right. Gold coins in the scavenger. Well, we know that Alice found 6. We know Davy found 5. Lucas found 6 as well. And Carter found 8. And we know that the mean of the data set is 6. So on average, they found 6 coins. All right. So what we're going to do is find the missing value. So I'm going to bring up the squiggly screen. All right. So the first thing you want to do is that we have 1, 2, 3, 4, 5 people, right? So we know that our number divided by 5 is going to give us our average or mean of 6, okay? Again, how did I get that? Well, we know that there were 5 scavengers or 5 people, right? So we have 5 total numbers. We're going to take the total of all the coins they found. Essentially, let's pretend we're putting them in a big pile of coins, right? And we're going to split those coins up amongst the 5 people. So keep sharing the coins equally amongst the 5 people. And when we're done with that, we would find that each person had 6, right? So how do we get to that? Well, we need to find this top number. So the sum, the total number. So we have 6 for Alice. Davy, we have 5. Lucas, we also had 6. And Carter had 8. All right. So what you need to do is add these up. So I'm going to add 6 plus 8, which is 14, right? 14 plus 5 is 19, plus 6 is 25. So, or you could do 11 plus 14, however you want to do it. All right, so 25 is the total number. But we know that this number up here, right? What divided by 5 gives us 6. So to do that, we'd have to multiply each side by 5. So 6 times 5 is 30. We know that 30 divided by 5 equals 6, right? So we have 25 accounted for, and we want to make it so that there's a total of 30. So that must mean that Julia found 5 coins. All right, so let's see. So another way of showing this that may help you understand is a mean is like we're distributing it equally amongst all the things. So let's say we take this. We know the average was 6, right? So we take this block. I'm going to call it block A, and this block B, right? Yeah, because you can see that. All right, let's give block A over here. It's gone there, right? And if we put block B here, they all have that same amount as before. So anyway, let me X out of that, and I'm going to type in 6 and, oh wait, not 6. Burp. What am I typing in? Oh, what number to get from here to 30? So it's not 6, it's 5. So let me go back. What did I do? How do you delete stuff? Oh, duh. It's been a long day. All right, so check. Good work. Woo. All right, so again, just to recap, you're going to take the number of pieces of data, right? We had 5 people here in this case, right? We knew from the question that the average was 6, and then we knew that we needed to get, when we solved this equation, the missing number the total had to be, all of these numbers had to add up to a sum of 30, right? So we had these numbers accounted for 25, so we know that this section needed to be 5. All right, so let me go to the next question with you. All right, next question. The following table shows each of Haruka's final exam scores last semester. Yikes, she better get studying, if that's, Haruka is a female, I'm assuming. Anyway, they need to get studying because 72 in astronomy, unacceptable. All right, anyway, biology, 85. I mean, we really need some good biologists right now. Physics, 92. That is not an easy class, kids. Chemistry, question mark. All right, if the mean of the data set is 84 points, find Haruka's final exam score in chemistry. So we're going to use the same method. We know that there is 1, 2, 3, 4 classes, right? So I know that the total score divided by 4, right? How did I get the 4? There's 1, 2, 3, 4 classes. And we know that the average has to end up as 84. Okay, so how would we solve this? Well, what number divided by 4 is 84? So to solve that, we're going to take 84 times 4. All right, so 84 times 4. That's 16, 32, 33. So 336 is the total that this all needs to be. All right, so what do we have accounted for so far? We have 72 in astronomy, boo, 85 in bio, and 92 in physics. All right, so we've got 9 here. We've got 17 plus 7, 24. Right, I just want to check this because I'm like having a moment right now. 5 plus 2, 7, 8, 9. 17 plus another 7, 24. All right, so we have 249 accounted for. Right, so all of this here adds up to 249. What must this number be? We want the total, when we add those, to be 336, right? So to find that, we need to subtract. So 336 minus 249. And I 100% don't blame you if you would like to use a calculator. You have my math teacher permission, for what that's worth in your household, to use a calculator on this. All right, so 87. Let's see if I'm right. So I'm going to type 87 right in that little box. All right, and again, how did I get that? Well, we need this to add up to 336. Why? We have 4 pieces of data. We know the average is 84. So we took these two numbers and we multiplied. We got, when we multiplied, we got 336, right? And we know that up here, 249 was what we had accounted for. So to get to 336, we're missing a score of 87. So let's go ahead and type in 87. 87, check. Woo-hoo. All right. Next question, and they gave us a bar graph. In statistics, they call them histograms, but with histograms, there are no spaces between the bars, so I don't know. I could argue. All right, raisins in a scoop of each brand of Raisin Bran cereal. Number of raisins. Oh, Good to Go has 9 number of raisins. They have 9 raisins in a scoop of that. We don't know about Great For You, but morning meal is 7. So we know the average, or the mean of the data set, is 7 raisins. It says it right. Oh, I'm underlining it. Find the number of raisins in each scoop of Great For You. So again, we have 3 brands of cereal, right? So I'm going to take the number and divide it by 3. And we know that there are 7 raisins. So that means when we add up all 3 of these, this whole total, including this mystery guy in the middle, it's got to be 21, right? Because 21 divided by 3 will give us 7 on average. All right, so now we know Good to Go has accounted for 9. We know morning meal has accounted for 7. So we have talked about 16 raisins so far, but we need to get to 21. So 21 minus 16 is 5 raisins. So picture that here. All right. So we need to have 5 more raisins to get that up to 21. So let me type that in. 5. Check. Woo-hoo. All right, next question. All right, the following, oh, you know what? Because I went through this before just to kind of look at the questions a while back when I assigned this, I'm wondering if that's why. I hope you guys have the same data set. If you don't, for some reason, it's not a big deal because you would use the same concept, all right? So you need to know how many pieces of data you have. That's the number that we would have divided by to find the mean, right? And then they're going to give you the mean. So then we just got to figure out what we're missing to get to that total number. All right, so the following table shows the number of police calls that were made last year in each of the cities in Ogden County. All right, so I have no idea if that is a lot or not. It doesn't seem like that many. Not that many calls. I mean, in Clarksville, that isn't even one. And in Shells, and in Bremerton, and in Gristle. Yeah, that's not even one call per day every day, right? So that's pretty good, I'd say. Because there are probably some people who call many times. All right. If the mean of the data set is 273 calls, find the number of police calls in Thornbury. All right, so again, we have oops, gotta grab the pen. We have 1, 2, 3, 4, 5 cities. All right, so 5. All right, we know that there are 273 calls on average. So we need to set that right there. Now we're looking for this number. So to find that number, you've got to do the inverse operation. So basically you're taking 273 and we're multiplying it by 5. All right, so we have 15, 35, 36, 1365. 1365. All right, now we need to figure out how many are here. Then what do we need to add to get this to be a total of 1365, if that makes sense. All right, so we're going to do some adding right now. So 244, 353. Let's add those two. It's 597. Check, check. We need to add in 235. I'll give you 12, carry the 1, 13. And that's going to give you 832. And we need to add in 311, 1143. So we have 1,143 accounted for, but we need to have a total of 1,365. So we're going to subtract to find the difference. That's going to be 222. 222 would get us to a total of 1365. So let's try it. We're going to type in 222. I felt like that was a little bit of a pause to keep things dramatic. Oh, there's the flying band-aids again. All right, done. All righty. Oh, you know what? Shoot, I should have looked at these before and just like went through it really quickly because now it's different questions. Good job. All right. Oh well, it's probably better that way anyway because then you guys can learn how to do it and then apply it without me just telling you the answer because, I mean, how much are you actually getting out of that then? I don't know. All right, anyway, effects of shifting, adding and removing a data point. So again, this is going to focus on that idea of outliers and how an outlier affects the mean a lot because it pulls the mean in the direction of the outlier. The median is fairly resistant to that. I mean, it can impact the median slightly, but it's usually never as much as the mean. All right, so it's really an effect on the mean. So let's take a look at this assignment at the bottom. Ready to practice? Okay, 4 questions. Show us what you can do. Yeah. All right, let's go. Okay, Brandon in the petting zoo. I think they had this question before. All right, Brandon works at a small petting zoo with 8 animals. That's a very small petting zoo. He was looking at some data showing the mass. Although, have I ever been to a petting zoo? I don't think I have. When I was a child, I mean, it was just like, go to somebody's farm. You didn't pay to go pet animals, but times are changing, so I don't know. Whatever. All right, Brandon works at a small petting zoo with 8 animals. He was looking at some data showing the masses of the animals. Each animal had a different mass between 2 and 160 kilograms. The zoo then buys a horse that weighs 900 kilograms as their ninth animal. So I wonder what animal would weigh 160 if a horse is 900. I'm not going to venture a guess because I'm just going to end up sounding really stupid. So I'm just going to leave that alone. All right. So 2 is a small animal. That, I swear, is my chair making noises. I am not passing gas in my math videos. I promise. I have restarted this video so many times. I would do it again if that were the actual case. But no, it's... Here, I'll do it again. My chair. I'm bumping into things in my office. Anyway. All right. Brandon works at a small petting zoo with 8 animals. All right. What am I answering? All right. How does buying the horse affect the mean and the median? So, we know. All right. I'm just going to draw this out a little bit. So, we got 8 animals. So, like 2 kilograms. Right. And then we've got 160. This is not drawn to scale, kids. And then all of a sudden, like, way out this way, like, way down the line, you have a 900 kilogram pet for the petting zoo, or the horse, right? So, that's what this guy we would call an outlier, all right? An outlier, whatever. It's a word you probably read more than you ever say, but I'm going to say an outlier because it lies outside the typical. All right, so how does buying a horse affect the mean and median? So, we don't know the masses of each of these animals, and there are 8, and we don't know all of them. We know 2 and we know 160, and then we know there's a horse in the mix that's 900, but we're missing a lot of the animals' masses. So we need to rely on that thing that I told you about, the outlier pulling the mean in that direction. So that is going to significantly pull up that average. All right, so we need to make sure we narrow it down to a question, or an answer, I should say, that talks about the mean increasing. All right, so that will eliminate C and D because it says the mean will decrease. Well, that's simply not true. You're not going to throw a 900 kilogram horse into the mix and think that the average weight is going to decrease. That's just not how that works, because that's higher than the highest number they had previously by quite a bit. All right, so you can just eliminate C and D just for common sense purposes. All right, so A and B both say that the mean and the median will increase, which is true, right? That's going to definitely bring up the mean. But the median will increase by more than the mean, or will the mean, excuse me while I yawn, but the mean will increase more than the median. Well, because that's such a huge outlier for these animals, like, you're probably talking like, see, here I go guessing, probably, that was my cat in the background warning me not to. Okay, maybe one's a cat. You go from a cat to a horse. I mean, I don't think a cat would be at a petting zoo. Where are they usually, like, pigs and stuff? But pigs are pretty heavy. But not 900. Oh my gosh, not 900 kilograms. See, this is why I wasn't going to guess, kids. But anyway, I'm rambling. This is what happens when Mrs. Lehman records YouTube videos at almost midnight. All right, so this is a case where it will increase, the mean will increase tremendously. So it is going to be choice B. Let me check. All right, so choice B. All right, next question. Well, la-di-da, who's Suzanne and her small business? Oh, wow. Suzanne's making some cash. Making bank. All right. Suzanne owns a small business that employs 5 other people. Suzanne makes $100,000 per year. And the other 5 employees make between $40,000 and $50,000 per year. Suzanne decides to leave the company and keep the other 5 salaries the same. how can you leave the company? If she left the company, she owns the company. She sold the company. And then these would not be her employees. But regardless, whatevs. Okay. Suzanne decides to leave the company and keep the other 5 salaries the same. I would have worded that. Suzanne left or sold the company, and the other people who work there, their salaries stayed the same, or something probably more eloquent than that. How will removing Suzanne's salary from the data set affect the mean and median? Well, look at this. Oops, let me draw. This is huge, right? Let me erase that. That is an outlier. That's going to pull the average down here somewhere, right? It's going to pull it up. Now, down here, if you take that out, the average now, so I'd guess, I don't know, I did not add these up, but it's going to be somewhere in that vicinity, a little triangle underneath it. The number line means that's the average. Oh, excuse me again while I yawn. Okay, so on this next one, the average is going to be like right there. Okay, so anyway, now, the mean, in this case, is going to increase, right? So the mean will... Okay, whoops. Let's see what we have for options. All right, so we need to make sure it definitely says the mean will increase. So A is garbage because it says the mean will decrease. That is not true. Oh, never mind. Burp, burp, burp. Rewind the tape. Okay, I'm sorry. I apologize. All right. How will removing her salary affect the mean and median? Not how does her salary affect it. How does removing it affect it? So if you remove it, the mean will decrease. So we're looking for one where the mean decreases. So I'm going to retract any previous rambling, and we are going with the mean decreasing. So we need to have one that says the mean will decrease. All right, so this says B says the mean will increase. That's simply not true. There is no way the median, when you remove that, like they're both going to drop, right? Mean and median. Or maybe not drop, but it's certainly not going to go, it will not increase. The median is not going to increase. All right, so we're going to get rid of A. All right, so we need to decide, and it's in the second half of the statement. It says both the mean and median will decrease, but the median will decrease more than the mean. The mean will decrease more than the median. Now we could do the math on this, but when you remove an outlier of that size, that means that the mean is going to decrease more than the median. I'm going to say D. Yay! All right. A group of 4 friends like to bowl together, and each friend keeps track of his all-time highest score in a single game. Their high scores are all between 180 and 220, except for Adam, whose high score is 250. Adam then bowls a great game and has a new high score of 290. I bet whoever wrote this problem, I bet their name is Adam. Anyway, how will increasing Adam's high score affect the mean and median? Well, it's definitely going to bring up the mean. All right. So you're not going to add a higher value in and have the mean stay the same. So B is garbage. All right. And if you increase a high score, the median's not going to drop if you're adding higher numbers in. Like, it may not change, but it's certainly not going to drop. So we've got to do some figuring here. All right. So the high scores are between 180 and 220, and then we add in, so we have 180, 220, and something in between there, right? And then we've got 250 here. Or it's going to increase to 290, right? So, yeah, it's going to increase them both. Wait, let's see. 1, 2, 3, 4. Actually, the median will stay the same because, all right, so we have 1, 2, 3, and we're picking between these two, right? So 1, 2, 3, 4 values, right? So if we have 4 values, the median is going to fall between these two values regardless, right? Regardless if we go the 290 or the 250, that middle value remains the same. The average will definitely go up, or the mean will go up. So it is choice C. Mean will increase, the median will stay the same. Woohoo. Oh, there's one more. Chucky. Chucky grabbed 11 items in the grocery store that each had a different price and had a mean cost of about $4.44. On his way to the register, he gave into an impulse, because it was probably his first time out in months, to add a 12th item, an entire wheel of cheese that cost $39.99. You sure this wasn't my husband? How will adding the wheel of cheese affect the mean and the median? Well, if his average price item was $4 and all of a sudden he buys a $40 wheel of cheese, that's definitely going to increase the median. The mean. All right, so the mean will increase. So let's eliminate D because that says the mean will decrease. Let's see. A says both the mean and median will increase, but the median will increase by more than the mean. Both the mean and median will increase, but the mean will increase by more than the median. The mean will increase, and the median will decrease. Well, the median is not going to go down, so it's either A or B. And just because it is such a high jump in price, that is going to be a situation where the mean is going to be affected greatly. Again, the outliers greatly affect the mean. All right, so it is going to be choice B. Betting money on it. Final answer, yep. All right. Show summary. Band-aids. Gross. All right, done. Oh, all right, so then other than watching these cool, awesome videos, there you go. Your math should be done. You just got to make sure you're signed in to Khan Academy. Otherwise, it's all for nothing. Make sure you're signed in and make sure you do all of these things. Excuse me, and I can see your score, and I can see that you're working on stuff. You can also go to past assignments and fill in anything that is red. I think you can go through and actually fix anything old too, but it'll do like what happened with me and give you new questions because they don't want you essentially cheating. So whatevs, do the stuff from the past if you owe me some of that stuff. Oh, excuse me. Well, it's about time for me to turn into a pumpkin before the clock strikes midnight. But anyway, there you go, kids. So, again, just to recap, when you're looking for the missing value, you need to understand that you're finding the sum and dividing it by how many values you had. You need to figure out, first step, okay, you've been given certain things, of pieces of this puzzle. First piece of the puzzle that you have is how many pieces of data you have, right? And you also know what the average is, so you can fill in. Excuse me, I keep yawning. You can fill in those missing things and then solve for what the total needs to be to get that average. So then you take all your data that you have been given, the amounts, add those up, and see how far away you are from the total you needed. So you do that by, after you add up all of them, subtract, right, from the total you need, or subtract the total you have from the total you need, and that's going to be your missing piece of data. And then I think you could tell hopefully from this last lesson that when you are dealing with an extreme outlier, it is going to have a significant effect on the average or the mean. It's going to pull it. The outlier is going to pull the mean in the direction of the outlier pretty significantly. And the median is resistant to that nonsense. All right, so it may be affected because, like, if you remove, instead of replacing a value, you just remove it, like, that's going to affect, the placement of the center. But other than that, it's not really changing the data very much at all. So, yeah, I mean, you're talking like wiggling the median slightly, but not anywhere near the same effect as the mean. All right, kids, I need to get this uploaded. So, again, give this a try. Go on IXL, practice those skills, and go back and get some of the stuff done. And on that note, I'm going to sign out and say good night. Thanks for watching Math with Mrs. Lehman. Make sure you hit the notification bell so that you can be alerted at midnight when I upload these fun instructional videos. Have a great day, guys.